Dear friends, in this video, I am going to discuss central limit theorem, which is module 6, that is part of the series Test Your Knowledge in Business Statistics in the Age of AI. Let me first give a background. Central limit theorem is the cornerstone of statistical inference. There are very many applications that require the assumption of central limit theorem in all areas of management and in the digital analytics world. What it primarily says is, regardless of the shape of the original population, it may be anything, maybe a skewed distribution, maybe anything. If you draw a random sample of a large size in a repeated fashion and continue to compute the value of the sample mean x bar, and then if you find out the distribution of all such x bars which you have generated, it will be a bell curve with mean of the population mu the same and the standard deviation sigma upon root n, which is called the standard error of the sample statistic. It's a hallmark in the world of statistics, the landmark discovery, central limit theorem. So, large sample in a practical world, how large is large? We say anything more than or equal to 30. That means at least a sample size of 30 is required in order that the central limit theorem be applied. So look at one example here. A retail chain wants to understand the average spending of its customers to tailor marketing campaigns. By collecting spending data from 500 randomly selected customers and using the central limit theorem, the sample mean is treated as an approximation of the true population mean, enabling accurate predictions about overall customer behavior. If there is no central limit theorem, we cannot do that. Your sample size is 500, but the central limit theorem applies because the sample size is 500. It's a great discovery. And without further loss of time, let me go to some MCQs. Question 1. A company wants to estimate the average time customers spend on their website. A random sample of 100 customers reveals a mean time of 15 minutes with a standard deviation of 5 minutes. Assuming the central limit theorem applies, what is the approximate standard error of the sample mean? The standard error is given by sigma by root n. There are 4 choices for you, A, B, C, D, and you may make a guess. So let me just flash the answer with explanation. 0.5 minutes, so choice A is correct. Explanation, standard error is computed as sigma divided by root n. Here, the standard error is equal to 5 divided by root 100. Sample standard deviation is given as, and the population standard deviation is given as 5 minutes, or we assume that because the sample size is large, and therefore 5 divided by root 100 is 0.5, and hence choice A is the right one. Question 2. A factory tests 210 randomly selected light bulbs and finds their average lifespan to be 800 hours. With a population standard deviation of 40 hours, what is the 95% confidence interval for the true mean lifespan of all bulbs. 4 choices are there, A, B, C, D. You may compute and keep the answer. Let me now give the answer with explanation. The choice is A, 795 to 805 is the confidence interval. Why? The confidence interval is given by the formula x bar plus or minus z times standard error, where z is the ordinate of the standard normal distribution, which will correspond to 95% confidence level. So standard error is 40, and there is a small typos here. It should be 210, and therefore, when you divide it by 40 divided by root of 210, it's approximately 2.76. And therefore, the confidence interval is 800 plus or minus 1.96 is the ordinate corresponding to 95% confidence level in the standard normal distribution. So 1.96 multiplied by 2.76, substituting here, you get 795 to 805 as the confidence interval. So choice A is the correct one. Question 3. A logistic company wants to estimate delivery times for a new route. From a sample of 36 deliveries, the mean time is 90 minutes with a standard deviation of 12 minutes. What distribution does the sample mean follow? Uniform, exponential, normal, Poisson. So 4 choices are there. So what's your answer? Central limit theorem applies. Therefore, choice C is the correct one, normal distribution. Why? By the central limit theorem, the sample mean of sufficiently large samples, at least 30. Here, n greater than or equal to 30. It is 36 deliveries. And therefore, it follows a Gaussian normal distribution, a bell curve, regardless of the shape of the original population distribution. So choice C is the correct answer, normal distribution. Question 4. A researcher wants a margin of error of plus or minus 2 units for estimating the mean of a population with a standard deviation of 10 units at a 95% confidence level. What is the minimum sample size required? A, 25, B, 50, C, 96, D, 200. The answer is choice C, 96. Explanation. The sample size is computed, n is computed by the formula Z sigma by E whole squared. Within brackets, the entire thing whole squared. Z sigma divided by E, the whole squared. So Z is 1.96 for the 95% confidence level. In the standard normal distribution, the ordinate Z is 1.96. Sigma is equal to 10 given. The margin of error is plus or minus 2. E is 2. And therefore, substituting 1.96 into 10 upon 2, the whole squared, which is equal to 96.04, rounded to the 2 decimals integer. It is 96 rounded now. Sample size is 96. Question 5. A company wants to estimate the proportion of customers who prefer a new product. If the estimated proportion is 0.5 and the desired margin of error is 0.03 at a 95% confidence level, what is the minimum sample size required? A, 600, B, 800, C, 1067, D, 1200. What's your choice? So let me plot the answer with explanation. 1067. 1067. That means choice C is the correct answer. For the proportion, the formula which you had applied in the previous question gets simplified as follows. N is equal to Z squared into P into 1 minus P, the whole thing divided by E squared. Z is 1.96, P is 0.5, and E is 0.03. You want a margin of error of 0.03. And therefore, upon substitution, 1.96 whole squared into 0.5 divided by 0.03 whole squared, it's equal to 2 decimal places, 1067.11. I round it to the integer 1067. 1067 is the right choice, and therefore the answer is 1067. Choice C is the correct answer. Thank you very much. We will see you soon in another module, maybe the next module. Thanks a lot.